2015 Leaving Cert Ordinary Level, Paper 1, Question 8. So it says here, the daily profit of an oil trader is given by the profit function this, P equals 96x minus 0.03x squared, where P is the daily profit in euro and x is the number of barrels of oil traded in a day. So it's saying to us, complete the table below. Okay, so to get the profit, they've got different values of x here. So to get the profit for each of these values of x, you're going to sub them in one at a time into this function. So let's do it for 1000. So to get the profit when x is 1000, it's a case of putting 1000 in place of x. So this is the function that we're dealing with. This is the profit function. Minus 0.03x squared. So all I've got to do here is replace my x with 1000. So 96 by 1000 minus 0.03 by 1000 to be squared. So let's see what that comes to. So for that, you're going to get 66,000. So that's the profit when the number of barrels traded in a day is 1,000. So 66,000 is going to go in here. And you just do that for every value of x. So let's just do it for the rest of them here. So for when you do it for 1500, you're going to get 76,500. For 2000 then, going to get 72,000. And then finally for 2,500. And as you can see here, I'm not showing my working out here. You wouldn't have to do it for all of them. So there's the profit when x is 2,500. And that's part A completed. Now in part B here, it's saying draw the graph of the trader's profit function on the axes below for x between 500 and 2,500. So we've got to plot points here. So we have a few points here. So 500. 40,500 is 1 point, so let's see what that would be. 500, 40,500. So 40,500 is going to be roughly about here. It's just between 40,000 and 41,000. 1,000, 66,000. 66,000 is going to be roughly about there. We've got 1,500 and 76,500. 76,500 would bring us up as far as about there. Make sure you've got it lined up correctly as well. The next one is 2,072,000. 2,072,000 is going to be somewhere here. And then finally 2,500 and 52,500. 52,500 is halfway between 50,000 and 55,000. So yeah, 2,500. So we're looking at exactly there. So now I've got a few points. So this is draw the graphs. You need to make sure you get a pencil when you're doing this and draw as smooth a curve as you possibly can through those points. Don't use a pen unless you're very confident sketching curves. Alright, so it's going to look something like that. So this is our profit function. b is equal to 96x minus 0.03x squared. And that's part B done. So in part C here it says use your graph to estimate firstly the daily profit when 1750 barrels are traded, and secondly the number of barrels traded when the daily profit is 60,000. So I can use this graph here to predict these two. So I'm looking for the profit when 1750 barrels are traded. So I'm going to go to my curve here and come up from 1750. Well, 1750 is exactly halfway between 1500 and 2000. So you're going to just get a ruler now and draw a smooth line up, hit your curve. So we'll go in this direction here and then come across. So it looks like the daily profit is going to there be 75,000. So that's going to be my answer there. And then the next bit says we want the number of barrels traded when the daily profit is 60,000. So there's actually two possible answers here, and we'll see why in a second. So this time, we're looking for X, not P. In the previous one, we were looking for, well, what's P? What's the profit when X is 1750? This time, we're looking for X when P is 60,000. So you're going to go to 60,000 here on the vertical axis, because that's where P is measured from. You're going to come across and hit your curve. So we're going to hit our curve in two different spots here. And that's why we're going to get two different answers. So our first answer is going to be there. And our next one is going to be about there. So from our graph here, that looks to be, well, that would be 750 there. It's pretty much exactly between 750 and 1,000 on my graph. So that would end up being 875. That's hard to tell exactly, but it's about a quarter of the way between 2,250 and 2,500. So we're looking at roughly a quarter of 250, which is about 60. So you don't have to be perfectly exact here, as long as you get it roughly correct. So I'm going to say 2,250 plus an extra 60. So that's going to give me 2,310. So these are going to be my two answers. So the number of barrels traded when the daily profit is 60,000 from my graph is going to be 875 or 2,310. And that's part C done. So then in part D here it says use calculus to find the number of barrels of oil traded that will earn the maximum daily profit. Now, so we want to maximize profit. So the profit function again was 96x minus 0.03x squared. So I want to maximize this. So you want to maximize something, what you do is you're going to differentiate it. So I'm going to be getting dp dx here. So differentiating, so I should say 96x of course. Differentiating 96x, you're just going to get 96. Differentiating this is going to bring the 2 down and multiply by the minus 0.03 here. So that's going to give you minus 0.06 and then take 1 away from the power of x. You're just left there with the x. What you're then going to do is you're going to let this equal to 0. Remember, you differentiate your function and let it equal to 0. And then you're going to solve it for x. So minus 0.06x is then equal to minus 96 And then you can divide minus, well, you can multiply both sides by a minus there if you want. So 0.06x is equal to 96. And then just divide the 96 by the 0.06. So let's see what that ends up being. So that's going to give you 1600. So that's the answer to that part. So they're looking for the value, well, they're looking for x really. They're looking for the value of x that maximizes the profit. So 1600 barrels of oil will maximize the daily profit. As we can see from our graph here, the maximum profit here occurs roughly about 1600. Now, but then it's asking us then to find this maximum profit. Well, this is my profit function. I know the profit is maximized now when x is 1600. So to find the maximum profit, I'm going to sub this value of x into that function. So you could call it Pmax now, if you want. So Pmax, the maximum profit. Again, I'm replacing my x here with 1600. You're going to have 96 multiplied by 1600 minus 0.03 by 1600 to be squared. As always, another job for the calculator, so let's see what that is. So that's going to give you 76,800 euro. And let's just check that on our graph here again. Yeah, you can see that the maximum profit occurs just above 75,000. So that answer there seems reasonable. And this is what you want to do. You want to ask yourself, does my answer seem reasonable every time you get an answer? So the last part here then is saying the trader will not make a profit if he trades more than K barrels of oil in a day. Find the value of K. Okay. So we want to find out, well, you know, if he doesn't make a profit, he's going to make a loss. So if you go back to the graph here, this would extend down to 0. Now, if the daily profit is 0, he's making no profit. So I'm going to find out when that happens, to find out what value of x for which that occurs. I'm going to let this function equal 0 and then solve it for x. So I'm looking. It does say k here, but the barrels of oil are measured. That the measured is called x in the question. So my profit function again is 96x minus 0.03x squared. So I'm going to let this equal to 0 because I don't want him to make a profit. So now I've got an equation here. So it's a quadratic. I can take x out there. If I take x out, I'm left with 96 minus 0.03x all equal to 0. Now I've got two things multiplied by each other equaling 0. So the first thing is equal to 0, or the second thing is equal to 0. So 96 minus 0.03x is equal to 0. So there's one value of x. The other value of x here is going to be minus 0.03x is equal to minus 96. Again, you're going to divide, you can cancel the minuses if you want, but you're going to be dividing 96 by 0.03. And that's going to give you 3,200. Now, it says here, the trader will not make a profit if he trades more than K barrels a day. More than. So this is not going to be our value of K, because if you go back to our graph here, if I extended this down, it would hit 0, 0. But we can see here that when he's trading, say, 1,000 barrels, which is greater than 0, he does make a profit. So that's why we're going to exclude here 0. But this one we are going to take, because if he trades more than that, if you look at our function here, it looks something like this. This value here, where it cuts the x-axis, will be 3,200. If he trades more than that, he's going to be making a negative profit or a loss. So the value of k here is that 3,200. And that is question 8 completed.